Doug will be providing everyone with a great technical overview and a few demos today. So now I would like to turn it over to you, Doug. Welcome.
Thank you. Hi, everyone. My name's Doug. I've been working with Oracle since version 5. Been working for Oracle as a consultant, developer, and product manager for many years. So let's get into it. So many of you may not know what vector search is, but you've probably used it every day. If you use Google search, you're using vector search. Likewise, Microsoft Bing. If you've ever searched for or tried to sell something on eBay, you've done vector search. So vector search is about finding similar things or related things. So that's quite high level. We're going to get into the detail. I've got a couple of demos. I encourage you to ask questions by typing them into the Q&A, and then we can answer the questions during the talk. So the whole point of vector search is that you take complicated things, text documents, images, audio or video, which are traditionally hard to represent and search in any technology. We take that information and we somehow encode it into a bunch of numbers. So a vector is just a bunch of numbers. In this case, those numbers have some meaningful representation of the text or images, audio, video, whatever. So the hard bit is, how do you get this complicated formats into a bunch of numbers? The good thing is you don't need to worry about that. The technology to do that is based on neural networks. You don't have to know how that works. You can buy them. You can use open source neural networks, or you can build them yourself. So these neural networks are called vector embedding models. What they're doing is converting this information, whether it's text, audio, video, or images, and converting it into numbers. Once that information is numbers, we can then do math on those numbers to find similar things. So that's all kind of high level. Let's have a quick demo to see how to do that in practice. What I have here is a very simple query application. It's 80 lines of Python code, and it's one SQL query to do similarity search. So if we did a search on animals, we get some answers. If I do some search on fruit, we get some answers. If I did a search on the UAE, I'm going to get answers. Now, the important thing is what I'm not doing. I'm not doing an exact search for the string UAE. What I'm doing is finding similar things. So in this case, Dubai is from the United Arab Emirates. Likewise, if I do a search for Mumbai, I'm going to find facts or information in my database about Mumbai. If I do a search on Bombay, I get the same answers about Mumbai. Why is that? It turns out a place called Bombay was recently renamed Mumbai because it's in fact the same place. So because information about Mumbai and Bombay are similar or related, you tend to get similar results. So what I'm not showing you here is a large language model. Instead, what I'm showing you is similarity search with vector embeddings. So that's sort of a subset of large language models. I'm going to talk more about that. The point is, these embedding models, which are just neural networks, are trained on data on the internet, whether it's text, audio, images, whatever. So where there's a correlation, or like when people talk about Mumbai, they might also talk about Bombay because it was renamed. So correlated or similar things tend to map to the same numbers or vectors. And then we do a search on those vectors. So let's let's look at how that actually works under the covers. I have a simple table with an ID, text, in this case it's varchar2, could be clob, and I have a vector. I'm going to explain more about the vector. So this is just a plain old Oracle table with a new type called vector. We look at the data. The text is just random facts or opinions that I typed in, and prior to this demo, I created the vectors. How I did that's a whole different discussion. We'll come to it. The point being, when I type in something like NY, I'm getting answers about New York. So when I type in something on the fly, I create a vector out of that query, and I compare that input query against the stored vectors. It's just doing some math under the covers, and it's showing you the most related or relevant answers. Now, in my database, I've only got less than 200 rows because I typed it in. So the point is, with similarity search, it's finding the most similar things in your database. So it's not perfect. It's the best available answer given the data. So if I type in something about New Zealand, which is where I'm from, it's not giving me facts about New Zealand because I didn't have any data about New Zealand. But what it is giving me somewhat related things. New Zealand's a place. These things are places. It wasn't giving me answers about fruit or animals or cars. It was giving me somewhat related things. So similarity search is about finding similar things given the available data. Now I see there's some things on the chat. I'm just going to quickly look at those. Okay, I'll come back to those questions later on. So any questions about what I've just showed at the moment? Okay, I'm seeing a question in the chat. So it's asking about the cost. So it's a really good question. The answer is, I don't know. Closer to the release date, this guy called Larry Ellison is going to make a decision based on the pricing. So in time, we will tell. So I'm just going to go back to the slides for a bit. So the point is, we took, in this case, text, which was just simple sentences which I'd entered in my database, converted them to vectors, and then did searches based on those vectors. I've got a later demo which, instead of getting data in the database and making vectors, I'm getting files in the file systems, PDF, doc, spreadsheets, PowerPoints, whatever, converting them to vectors so that I can do searches on data outside the database using vector search. The embedding model that you use is very important. This was for a Japanese customer. The point being, if you're doing it in English queries, there's a ton of embedding models for English out there. If you're doing it for non-English models, you need to use a multilingual embedding model, which covers virtually all languages. And in this case, we were doing Japanese specific ones. So to summarize what I was doing, generically, using similarity search for any technology, you're taking data, you're embedding the query, you're comparing the query vector against the stored vectors using math, you're getting a result set and returning it. So I was showing the five closest answers. If I search for more, I'm going to get bigger answers. So you're not returning everything, you're returning some result set size. So for instance, with Google search, you're going to get, say, 10 or 20 answers per page in many pages. I quite frankly virtually never go beyond page 1. It's not on the first page, I don't really care. So we're limiting our result set based on how much you care. So you could have a bigger number.
Hey, Doug, we have a question here. How is the search done by us, and is it able to identify the correct vector?
Great question. Let's look at the code. So this, I said it was a Python program. It's about 80 lines. This is running in OCI data science, but you can run it standalone. So this is running live. So this is the source code. And to run the application you just saw as a single SQL query, this statement. So I'm selecting the text, go to my data model. I've got a column called text. My vector is called text v. So I'm selecting the text from my table, and I'm ordering by a new SQL function called vector distance. With vector distance, it's doing the math for us. It's comparing the vector column with the bind variable of the input query. And I'm using a particular math comparison. In this case, it's dot plot product. You could also use cosine similarity, Euclidean, Hamming, or Manhattan. What those are don't really matter. There's just different ways of doing math. I'm just using this as an example. So exactly how all the math works, happy to talk about that in detail, but the point is 9 times out of 10, you don't even need to care. Just use the default and it's going to work. So I'm selecting some data. I'm ordering by the vector distance. The closer the vectors are, or the smaller their distance, the more relevant they are. So this is an ordered result set. The first row is the closest answer. The second row is the second closest answer. So in vector terms, the closer mathematically the vectors are to each other, there's a strong correlation with how related the real world answers are. So that's a convenient fact. Similar vectors tend to have a good relationship or correlation with the facts associated with them. So I just talked about cars, and given the cars, that's some answers. So going back to the code, I was doing the vector distance. I was limiting my result set. So that entire application is powered by a single SQL select statement. So this is as easy as it gets. You can obviously return more columns in your result set. You can do joins. You can do nested subselects. You can have with clauses. You can do analytics. You can go to town, because this is just a SQL function that can be used anywhere where a SQL function makes sense. And this is just a type. So what we're doing at the end of the day is SQL. So how accurate the answer is depends on two things. How much and how relevant your data is, and how good the vector embedding model or neural network that you used. So the simplest way to create vectors is a random number generator. It's really easy to use. It's fast. It's free. The quality of it is zero. It's completely useless. So the neural networks that create the vectors, the better quality of those vectors, the better answers you're going to get. Okay, next question.
Yeah, Doug, how does vector distance know the model being used?
Great question. This is the thing. So the vector distance, like the vector embedding model can be trained in different ways. If the neural network was trained given cosine as the function, you would want to query and pass in cosine as the parameter. If it was just XY coordinates, you could use Euclidean. I'm using dot product. So the vector embedding model will tend to determine the vector distance function that you use to do the query. So you get to choose the embedding model, and you get to choose the vector distance function. Most of the time, it's obvious what one you should use. If it's not obvious, you just try different ones until you get a good answer. It's probably the most difficult thing. You might have to try 5 different values as vector functions to get the answer. In reality, Hamming and Manhattan, you probably won't be using, or you will know when you want to. So you've really got 3 choices: Euclidean, dot product, or cosine similarity. Are there other questions?
Nope, I think we're good for now.
Alrighty. So at a high level, that was similarity search for text. We had converted the query text into a vector. We compared it against the stored vectors. And the way we did it was this function. It did all the math for us magically. If you've done Pythagoras theorem, the distance of the hypotenuse, the long bit, is for Euclidean for 2 dimensions, how it works. Real vector embedding models don't have 2 dimensions, they have hundreds or thousands. But the math doesn't change, it's linear algebra. So whether you're using Euclidean math or cosine similarity or dot product, it's just different math functions, it's all linear algebra. You don't have to understand the math, this function does it for you. You point to the vector column, the input bind variable, and the math function that you're using to compare. So, in a nutshell, that is similarity search. What I'm going to talk about next is large language models and how vector databases can help large language models. So, you've probably heard of ChatGPT. It came out about a year ago, and it's an example of a large language model. And what's important is it actually works. You know, years ago I did neural networks and AI. The problem was it didn't work very well. With modern technology, like a type of neural network called transformers, which Google invented back in 2017, not only did it work well, but also allowed you to train it in parallel, so it became cost effective. So large language models are useful for lots of things. You know, my kids use it for generating essays for high school. So that's one use. But you can also use it for business. One of the problems with large language models are trained on data in the internet. You know, usually it's text data. So they collect lots of text and they learn, for want of a better word, about the associations between those words and sentences, and in some cases, what it means. And you can ask natural language questions. In my case, it would be English, and you get an answer. Most of the time, the answer is good. But sometimes the answer is bad. If the information the large language model has doesn't match the question, large language models will tend to make up an answer. They've got a fancy word for it called hallucination. They are making up the answer. The problem is, it may not be obvious the answer was made up. So unless you're a subject matter expert, you may get a very formal, credible sounding answer from a large language model, but it may be complete lies. So that's a problem. Another problem with large language models is they're only as good as the data they were trained on. So it can take days, weeks, months to train large language models. And that's very expensive to do, costs a lot of GPUs, literally costs millions of dollars. So large language models are inherently useful up to the date where they're trained. So if new facts come along, the large language model might say, I'm sorry, I don't know about that. That's a good answer. The bad answer is, the answer is blah, 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 which is something it made up. So what vector databases can do is a couple of things. They can augment or add to large language model new facts based on your database, current up to date, correct to the millisecond as per your data. So you can effectively add new information to a large language model without having to retrain and fine-tune the large language model. So if you think about it, what we just did, or what I explained was, instead of asking the large language model directly, you can ask your vector database first questions based on information in your organization. So that's private information in your databases or on your files on your file system that is not publicly available information. So you can ask company-specific question, which you can then format as a prompt to pass to your large language model. So you can use the inferencing capabilities of the large language model with up-to-date information from your organization. So from a security point of view, if you had a local large language model, everything is contained with your organization. If you send it to ChatGPT over the internet, you'd be giving away private information. So you probably don't want to do that. So running a large language model locally is quite easy. I've done it, takes less than 5 minutes. There's lots of different large language models. They keep getting better every day. The point being, with a vector database, you can add local private information which is relevant and only known to your company to a large language model, preferably local for security reasons. So that's going to give you up-to-date information based on not only generic information from the internet, but also private content which is specific to your company. So this whole thing is called retrieval augmented generation, or RAG, because we're augmenting or adding to the large language model local, secure, private information from your company. So that was RAG. Any questions on that?
Yeah, we've got a few questions, Doug. One specifically to this is how can we assure the private information to the LLM is protected?
Great question. So I think I kind of answered that.
Yeah.
If the large language model is within your organization or within your tenancy in the cloud, any information sent between your vector database, your relational database, and your large language model, if it's within your data center or within your tenancy, it's not being shared with the outside world. If you were literally sending it over the wire to OpenAI.com, even though it would be sent over a SSL or a TLS network connection, you're literally giving away your private information. I think that's a bad thing, but that's your choice.
Great. We've got another question here, Doug. It's regarding Oracle Soundex, and they were interested how accurate Oracle Soundex is in comparison to vectors.
That's a good question. So remember for my demo, so I scroll back. Soundex or doing a substring search only works when the substring you're using exists in the data. I'm searching for UAE. UAE does not exist here. So I've used Soundex and substrings in Oracle. I do not believe that Soundex can do this because whatever regular expression you use or Soundex won't work because it's not of the right form. This is a more general solution. Having said that, I work for the database organization. We're working very closely with the Oracle Text group, which is part of the Oracle database. And all of the technology for Oracle Text that they've been using over the last 20 years, we're also adding into Oracle AI Vector Search such that you can do hybrid or combined similarity search plus using Oracle Text indexes. So we have a hybrid index which combines the best of similarity search and text search in an index to get the best of both worlds. It's another question.
Great. One final question here, and I guess the question is regarding availability. will the vector search be available on OCI Cloud or on-prem database? Is there some timing to that? Which one might be first?
Great question. So Oracle AI Vector Search will be released as part of Oracle Database 23.4. So that's going to be later this year. What's available today is what we call a limited availability program. What that means is we used Oracle 23C as the release mechanism, and we added AI Vector Search to that. So if you ask nicely, I can give you access to that software. The gotcha is, because it's 23C free, we limit the CPU, memory, and storage that you can use. For limited availability 2, which we plan to release in March, you can either have 23C free, there's no licensing, you can do whatever you want with it. Or if you need the Enterprise Edition because you need lots of storage, lots of memory, lots of CPU, whatever, you can do it. But you got to sign up to the Oracle Database 23C beta program. So this is available today. This LA2 will be available March, and the GA product will be available in Oracle 23.4 later this year. As to, so the LA1 software, it's a Linux RPM installer. You can run it on-prem, you can run it in OCI. I've tested in AWS. It'll run anywhere that Oracle Linux runs. So the question is, how will the Oracle AI Vector Search feature be bundled in different SKUs in Oracle Cloud or on-prem? Once again, I don't know. Larry Ellison will make that decision closer to the release date.
Just to add to that real quick, if you are interested in the beta program, feel free to reach out to me, and I can offer you some guidance there. And then one final question here popped up, Doug, is it mandatory to have a relational database? Is it possible to save the data in the vector database itself and then use it for the LLM?
Great question. I'm going to hold that question for 2 slides and then answer it. So I just want to go back to the slides for a second. So great question. So Oracle AI Vector Search is not a new vector database. What it is adding vector capabilities to the Oracle database. So over here, this picture represents the Oracle Converged database. We can do relational stuff, columnar, graph, JSON, spatial, machine learning, all sorts of things. This is representing, and we can also add vector processing. So a vector is a new type which you can use in a column in your database. So this thing here, that vector is a type in a column. So when we look at the data, it's just a bunch of numbers. The vector distance is an example of a SQL function to figure out how close or similar the distances, excuse me, between vectors. So that's a SQL function which you can use wherever you can use a SQL function in a SQL statement. So it could be in the select list, it can be in the order by list, you can do joins, you can go to town. And the third thing we added is vector indexes to make the queries go faster. It turns out the existing indexes that you have in Oracle databases don't work with vectors, because vectors aren't single things like numbers or strings or dates. They are a set of numbers, so you need to have special vector indexes. So I just wanted to show this picture, and then I'll answer the question that was asked. There are lots of vector databases out there. They're relatively new. But vector databases have a fundamental problem. They need to get their data from somewhere. So if they got their data from their business database, the enterprise database, whatever that may be, you've got to get the data out, you've got to push it over to the vector database and vectorize it. And then you can use the vectors. When there's new data, you got to push it over. When the data are updated, you need to push it over. When the data is deleted, you got to remove it. So what we have is an inherent data consistency problem. It's just like a data warehouse, operational database, data warehouse. With a vector database, you want to do queries right now based on data that's true right now. Data that's a day old or an hour old or even a minute old may be useless. So this is a fundamental problem if your vector database is separate from your enterprise database. So we've avoided this problem by making the vector database the same thing as the business database by just adding a column, which is the vector. So the vector is in the same row as your data. And when the data changes, the vector can be updated automatically, either via a trigger or asynchronously through some sort of batch job, whether it's DBMS scheduler or your other favorite type of scheduling. You know, using cron, it's up to you. So what I'm saying is, don't have a separate vector database. Make vectors part of your database. So could you ask the question again? I think I answered it.
Let's see. Oh, hang on a second here. Okay. Go through the questions here. Is it mandatory to have a relational database? Can't we save the data in the vector database itself and use it for the LLM?
Right. So if you had a separate vector database, of course, you could store your vectors in your vector database by the way you'd need to store the data as well. So that's possible, but I'm saying it's a fundamentally dumb thing because the data is always out of sync, whether it's from the data enterprise database or from the file system. So by making them all the same thing, you avoid that problem. You're not passing. So a large language model is a thing. When you're doing retrieval augmented generation, you're not passing, well, you are kind of passing the data. You're doing a query, the result set, you're converting into a prompt in the format of the large language model. So I'm from Oracle. I work for the Oracle database. We store our vectors in the Oracle database. Those vectors can be passed to the large language model when you're doing retrieval augmented generation to get more up-to-date, correct answers based on private information. I think that's answered the question.
I think so. Doug, we've got another good question here.
Sure.
When you're performing a vector search, aren't we supposed to use the quote same vectorization for the query condition bind variable as was originally used to populate the vector column in the table?
Thank you for asking that question. That is the most important question, and the answer is yes. It absolutely needs to be the same vector embedding model. If you encode your vector in one format and do a query vector in a different format, it ain't going to work. You're going to get garbage. So that may not be obvious. Thank you for asking that question. It is fundamental. So that answer is independent of technology. Pick your favorite database, pick your favorite vector database, pick your favorite embedding model. It's always true no matter what technology you use. So that's, if the only thing you need to remember from today is the same technology embedding format for the query and the data needs to be used, or else it won't work.
So Doug,
just hold on. Just having said that, the embeddings for the large language model can be independent from the vector database. So for instance, you can use OpenAI's ChatGPT as your large language model, and you could query it using vectors from Cohere or vice versa. Or you could use open source embedding models. So the point being, the embedding of the query and the data for similarity search has to be the same, but that can be independent of the technology and embeddings used by the large language model because they're independent.
hey,
Next
Doug,
question.
so you're saying to create a trigger to call the embedding model for the new operation data?
That's one way of doing it. So you can create your embeddings outside the Oracle database in your favorite language. The example I was showing before was using Python to do that. And you can use it inside the database, and I've got a demo for that. So I'm just going to hold the questions for a bit. I want to do a couple more demos, a couple more slides, and then I want to spend the remainder of my time answering questions. So loving the questions, just hold on to them for a minute. So because we haven't built a new vector database, because we've added vectors to the Oracle database, we get all the cool stuff of the Oracle database for free. So rack, sharding, Exadata, security. So this, excuse me, this may not be obvious, but most vector databases out there do vectors really well. But what about security? What about backup and recovery? What about ACID transactions? These really obvious things flat out don't exist or don't work very well in vector databases because they're fairly new and the people that built them know about vectors don't really know about databases. So we've got basically 40 years of excellence in database. We added vectors because they were fairly easy to add on. So you're getting all of the benefits that you currently get for your Oracle database in whatever configuration. Vectors are just a new type with some SQL functions and indexes. So I'm just going to do a quick little demo here. Just bear with me. I just created a vector. It's that simple. We've done this demo. We've already talked about this. The next demo I want to show is getting data from files on your file system and vectorizing those files so that you can do similarity search on your files rather than data in your database. So you've probably got lots of different types of files. Are they PDF? Are they Word documents? Are they spreadsheets? Are they PowerPoint? Are they XML? Are they emails? The answer is all of the above. So we're using technology from Oracle Text where we can convert 150 different types of files into plain text. Now, is a file small, medium, or large? It depends. You can vectorize anything, but to be useful, you want it to be based on a bite-sized chunk of that data. So if you vectorized a large book like War and Peace, the vector is not going to be that useful. So you tend to want to break it up into smaller chunks so that the vectors are more meaningful to a smaller thing. So as a chunk, a sentence, a paragraph, or a page, that's the sort of thing that you determine programmatically. So you've got a lot of control over that. So you convert it into plain text, you chunk it up into smaller bits, and then you vectorize it. So when you've got vectorized data, you can then do search against it. And then you can say, oh, I know the document and chunk that came from. So the point being, you can do similarity search, not only against data in your database, but you can do it from data from your files and your file system without moving them. So bear with me. So for my demo, we've got a bunch of files here: PowerPoint, PDF, docx, XML, XLS, bunch of different stuff. This is the end result. It's already run. I just want to show you that first. I'm going to then truncate all the data and run it again so you can see it running. The end result is you're going to have a unique identifier for your documents, a unique identifier for each chunk, the chunk itself, and the corresponding vector. So that would lead.
Yeah, Doug, can you quickly specify the size of the chunks?
You choose the chunk. Is it a paragraph? Is it a sentence? Is it a page? Is it 200 words? You choose that via metadata. We've got a little grammar in JSON for you to specify that. So the point being, the end result is you get doc IDs, chunks, and the corresponding chunks for the vectors. So got a little program somewhere. So if I run this program, it's a little Python program that's looking at a directory and it's going to convert those files. So if I run it, it's doing nothing because it's already processed those documents. It's just running in a loop with the sleep. So I'm looking at the file name, the file size, and a hash of the file. So if the file gets modified, I'll reprocess it. If it's a new file, I'll process it. So because I'm doing a sleep, it's not very expensive. All of this is done in a single SQL. It's actually a pure SQL statement. I'll show you that in a second. So there's no data to process. If I truncate the tables, it now has data to process. This is it just did a 22 megabyte file. So it's processing through those things. Oh. So just hold on a second. I was supposed to show you the empty tables. It's already done it. It's quick. I'm going to Control C it. Bear with me. Truncate. Just broke my demo. Pretend that didn't happen. Right. So I took the data, converted it to plain text, broke it up into chunks, and vectorized it. I did all of this I happen to use a Python program, but you could do it in your favorite language because, as you'll see in a second, the way I did it, I did an insert as select, and the select was from this PL SQL, the PL SQL table functions. So this is called Oracle Chain. So if you've heard of LangChain or Llama Index, this is the equivalent done in PL SQL. So Oracle AI Vector Search works with LangChain, works with Llama Index, but if you want to do it all inside the database for performance or security reasons, the way of doing it, so the point being, this PL SQL package function converts your document formats, PDF, XML, whatever, into plain text. That breaks it into chunks based on the metadata that you provided, and that creates the vector embedding. It's all a SQL statement, so you can call that from your favorite language. Is that JDBC? Is it Rust? Is it .NET? Is it COBOL? It doesn't matter. It's just a SQL statement. It just works. That's a new PL SQL package. Just looking at the time. So there's a bunch of questions. I just want to show a couple more demos, summarize stuff, and then I'll spend the rest of my time answering questions.
Hey, quickly, just Doug, will this chain loop program be shared on GitHub?
Absolutely. So I've written a bunch of programs as examples of how to do it. I've got a live lab for AI vector search. I've got a whole series of live labs. So all of these sample programs that I wrote will be on GitHub when it's GA. Until then, they are provided to customers in the limited availability program. So if you ask nicely, I can give you this stuff straight away, but you need to be signed up in the limited availability program. So that was a demo. This demo is creating vectors inside the database. This is pre-recorded, just bear with me. This demonstration is using AI vector search to create vectors in the Oracle database. Here, we're using the SQL vector embedding function to convert a string into a set of numbers, which is a vector. You choose the embedding model to determine the type of vector you get. You can either use a literal string as the input or a bind variable value. We choose the embedding model based on sentence transformers from Hugging Face. Here are some examples of the sort of sentence transformers that work with Oracle AI Vector Search. So just to summarize that, there's lots of free open source embedding models on a website called Hugging Face. That's where everyone puts their examples. If you Google it, you'll know what I'm talking about. Vector indexing, to make databases do fast queries, you need some sort of index. Vectors have their own special sort. We use the two most popular. One of them is an in-memory vector called HNSW, Hierarchical Network Small World. If you Google it, it's very common. It's the most popular type. Very fast, but it has to all fit in memory. If you've got billions or zillions of rows, it's probably not going to fit in memory. So we've got a disk-based database, sorry, a disk-based index called IVF flat. It turns out this sort of index structure works very well in parallel, so you can be searching subtrees in parallel. If you combine that with partitioning and rack or Exadata, this can be incredibly fast for infinite sized indexes. This is faster, but it has to run in memory. It's just index stuff. Now, I think I've covered everything. So I just want to summarize, and then I'll spend the remainder of my time answering questions. So AI vector search is a new feature of the Oracle database, which will be released in 23.4. We've got a new type, which is called vector. So the vector is the list or array of numbers, which was created via the embedding model. We've got SQL functions like vector distance or vector embeddings, which has been added to the Oracle SQL language. So vector distance is finding the closest or most similar things. Vector embedding, I just showed you the video of that. That's creating vectors on the fly. So whether you create the vectors in your program from embedding models that you built yourself, or open source, or embedding models that you paid OpenAI or Cohere from, we don't care. A vector's a vector's a vector. It's just a bunch of numbers that you put in there. So we don't care where you get your vectors from. However, you should care about the quality of your vectors. Random numbers are not useful. The better the embedding models are, the better the training for the neural networks for those vectors, the better results you'll get. So you want highly accurate vector embedding models for it to be useful. And you want it to be fast. It tends to be that the most accurate vector embedding models are not always the fastest. Tends to be. So choosing the best vector embedding model is difficult. I've tested over 30 of them. I've got a ton of examples of that, which makes it easy for you to try different vector embedding models so that you can choose based on your organization the most appropriate one. Do you just want to go with OpenAI and vector embedding models? Do you just want to go with Cohere? Or do you want to go with open source ones? With open source ones, there's literally hundreds. So figuring out the best embedding model for your language, for your business use case, is not a simple answer. You need to literally try it and see. So my sample programs make that easy for you to do. So we've got a new vector type, SQL functions to make it go fast or create vectors on the fly, and vector indexes to make it work. So I think I've summarized everything I want. I want to spend the rest of the time just answering questions now.
Doug, we've got a couple here, real quick. How does the quality of the result compare between vector database search and Oracle vector search?
Can you repeat the question?
Yes. What's the quality of the result comparing between vector database search and Oracle vector search?
Okay, I think this is a confusion. Oracle AI Vector Search is the name of the new feature which we're adding to the Oracle database. So those two different things that you asked me to compare, to me, they're the same thing. So maybe I misunderstood the question.
Yeah, I'll see if we get some clarification. That's kind of how I read it as well. Another person was wondering, is there any rig demo?
We have several RAG demos. I haven't showed it today. I went through what happens under the covers. Running a RAG demo, you can't actually see anything. It's just a chatbot. You ask questions, you get answers. The benefit of RAG is you tend to get better answers, and those answers may be up to date because the information came from your relational database. Yeah, up to date and domain specific or specific to your company because the result set from your vector search was passed in as a prompt or context to your large language model. So that's what's happening under the covers. To you and me as a user, you just see a chatbot and you tend to get better answers. So we've got a couple of RAG demos. We've got some on GitHub. I'm happy to do a follow-up to do those demos, say, this is how we do it with LangChain. This is how we do it with Llama Index. This is how we do it with PL SQL. There's a bunch of different ways. That's a whole talk in itself. But
Sure. And then
how it
also, Doug,
works, I showed.
on the landing page itself for these 23C sessions, I've got a resource section where I will be posting the replay as well as well, not the actual replay. We can't do possibly we may have to do a sanitized version just for confidentiality purposes. But the point is, on the resource section, I can provide resource links on this topic. So there might be some links to the demos, to GitHub, and some other areas that I could put up there, and it makes it really easy for them to go to that particular replay section and have access to those quick links.
Yeah, and just to add to that, when we go to GA, I'm going to have lots of examples in GitHub, live labs, blogs, you name it. Because we haven't released yet, I am constrained on what I'm allowed to make public.
Perfect. We have a question here. Does the embedded model have to be from the same vendor as the LLM?
The answer is no. I answered that. Those two things are independent.
What
However, I
differentiates?
just want to clarify the vendor for the embedding model and the particular model used has to be the same for the vectorized query and the vectorized data. But that answer is independent from the LLM. So Cohere vectors can talk to an OpenAI LLM and vice versa. Likewise, you could use open source vectors talking to, Cohere, OpenAI, or Llama, mix and match.
Great. We've got time for just another question or two, and then we have to wrap up, unfortunately. Doug, what differentiates Oracle Vector Search in 23C from Llama Index and LangChain?
Great question. So that's a fundamental misunderstanding of the difference. LangChain and Llama Index are frameworks. They're cool technology. We support them. Their purpose is to be a wrapper or the glue to talk to any LLM as a backend, any vector database as a backend. So they're a high-level framework. They are not an LLM. They're not a vector database. They're a wrapper that talks to LLM or talks to vector databases. So those are technologies that we support. We've built Oracle plugins for, excuse me, Llama Index and LangChain. So they're not competing technologies, they're complementary technologies. So whether you choose to use Llama Index, LangChain, or go directly to Oracle versus SQL or PL SQL is a choice that you as the customer make. I don't care what technology you use. It's a means to an end.
Okay. Hey, Doug, we're going to do a quick lightning round, and then we have to wrap up. It's great. We're getting so much interesting questions in this. So we'll start the lightning round. We'll see how quickly we can go through this. What LM model does Oracle 23C Vector Search use? You may have already answered this.
We don't use any. We're independent. We can work with any. We can work with OpenAI, Cohere, Llama 2, you name it. A vectored database is independent from an LLM. They can be used with each other. We can use any. There's no constraint, no restriction.
Okay, how is the embedding model stored to be referenced by SQL functions within the Oracle database?
We load it into a Oracle machine learning model. There's a PL SQL API to do that. You give it a name and you call it the name.
Perfect. Hey, how do videos, images, how are they loaded into the database? Is it using a script like Python, which you showed, or do we have any Oracle utilities to do that?
It's real simple. Images, audio, videos are stored in a blob. You use your favorite SQL API in your favorite language to do it. So, there's 10 different languages, 10 different APIs. Use your favorite one.
Perfect. Is chunking just a trial and error thing?
Kind of, yes. How big the chunk is how big you want. Do you want small, medium, or large? You literally need to try it to see what works for you. Once you've figured it out, you standardize on that.
Perfect. Okay. We'll wrap this up. I guess a couple questions on where you can get more information about vector search. You certainly can go out to oracle.com. Doug's got some great content out there. You can certainly look at the resource section of our series page for these sessions, as well as you can drop a note to Doug or myself, and we can provide some more information. So with that, thank you, everyone. Our next session will be coming up on February 1st. It'll be JSON relational duality. So encourage you to join that one as well. And Doug, thank you very much. I've got great feedback, about your presentation and how informative it was and very well presented. So thank you very much. And we'll talk to everyone soon. Take care.
Thank you.